Hello, my dear students. Welcome to the session. Last session, we discussed many problems on inductors and capacitors. As a part of transient analysis, I told you already that we have inductors and capacitors, initial conditions, differential equations, and Laplace transformations applications. Okay. So today, in this particular session, we are going to discuss on the initial conditions. That is the topic. But before I discuss initial conditions, application of differential equations, application of Laplace transformations, I would like to give you some introduction about the transient analysis. Different terms let us define, and we also discuss why we go for transient analysis, where it is required, okay, and why transients are occur. All these things, important topics or important definitions we will discuss, because they're all very, very important conceptually, and when you face any interview, they're going to be very much useful. Understand all of you? Okay. Therefore, let us look at some important definitions. Now, I would like to just list out what are the first. Okay. What is a steady state? One should really know about what is a steady state. Steady state or equilibrium state. Steady state or equilibrium state. Transient state or dynamic state. People call it transient state or dynamic state. Okay. Third one is why transients occur. Why transients occur. What are the initial conditions, or why initial conditions? Why initial conditions? Let me put one more here, fourth one. This is the fifth one. This is the fourth one. Objective of transient analysis. Objective of transient analysis. Why we should really go for transient analysis? Okay. What is the objective of transient analysis? Why initial conditions? Definition of initial conditions. Definition of initial conditions. Okay. And application of differential equations and Laplace transforms and all those things we will discuss. Okay. So I think all of you might be understanding now what are the topics that we are going to discuss here. First, let us start our discussion with steady state. What is a steady state? How do you define a steady state of a particular system? Whether it is an electrical system or mechanical system or chemical system, biological system, any system. Okay? As a matter of fact, any system you take, a system whose output is constant for a long time. Yes or no, all of you? Then that particular system is said to be what in steady state. For example, I'm here for a long time, continuously, without changing any displacement in the position of the body. Then I'm said to be in steady state. A fan is rotating with, let us say, 1000 RPM continuously with a constant speed of 1000 RPM. Then it is said to be in steady state. An automobile on a highway road is running with a speed of, let us say, 100 kilometers per hour, continuously, constantly, continuously with a constant speed. Then you can say that automobile is in steady state. Yes or no, all of you? What does it mean? Any system, okay, if it can produce a constant output for a long time, then that system is said to be in steady state. Yes or no, all of you? Okay. Now, what about the transient state? It is a state of the system in which the output of the particular system is changing with respect to time. Yes or no? Then that system is said to be what? then the system is said to be what? In transient state or dynamic state. So it's very clear. It's very clear. Initially, the system is in steady state. Okay, it is steady state. Usually, any stable system will definitely reach to a steady state. Let us say, initially, a particular system is in steady state 1, let us say, or equilibrium state 1. All of you look at here. I'll give you sufficient time to note down. I will also dictate some important points, but first you look at this. Equilibrium state 1. Okay. Now, you are applying certain amount of disturbance on it, or else suddenly some disturbance has occurred in the system. What will happen? If it is really a stable system, it will definitely reach to what? Another equilibrium state. Agree, all of you? Okay. If it is a stable system, when a disturbance has occurred suddenly, intentionally or unintentionally, whatever, some disturbance is taking place. Some disturbance is taking place at t equal to 0, disturbance occurred. Okay, disturbance occurred. At t equal to 0, when the disturbance occurred, then the equilibrium state of that particular system got disturbed, and it will reach to definitely another equilibrium system because the given system is a stable system. You understand, all of you? Okay. Therefore, it will reach to what? Steady state 2 or equilibrium state 2. If it is an unstable system, there is no point in reaching the steady state. Yes or no, all of you? So I am working on the stable systems here. So my entire discussion, whatever I am going to carry on here, the entire discussion is carried on here. That is completely on what? The stable system. Understand, all of you? Okay. Well, now the system, okay, whose steady state got disturbed and entering into another steady state, do you think the system will reach to another equilibrium state in 0 time? No, not possible. I'm here for a long time and somebody applied a force, then I'll reach to another equilibrium point. But do I reach that another equilibrium point, second equilibrium point or second steady state point in 0 time? Is it possible? No. What is the reason for that? Because of the inertia offered by the body. Yes or no, all of you? Because of the inertia, the body may not accept sudden change in its displacement. Yes or no, all of you? Okay. Therefore, it will take some time. And the time or the state of the system, now this is in a state where the response, where the output is changing with respect to time. Understand, all of you? Okay. Now, this is called transient state. I hope you understand this. Now, in this particular, okay, duration, the system is said to be in transient state. So, initially the system is in steady state. Suddenly some disturbance has been taken place. Then it will enter into transient state. But finally it will reach steady state after some time. We don't know how much time it does take. It all depends on the system. Okay, it all depends upon the system and its characteristics and everything that we will discuss later. Okay, but it will definitely reach what? Next equilibrium state or next steady state. Before it reaches to the next equilibrium state, definitely the system will be in transient state. I hope you understand the point, all of you. Okay, now what is the objective? I think you understand now what is the steady state, what is the transient state. Now, why transients occur? What is the reason for that? Okay, why the transients are occurring? See, we had about inductors, capacitors characteristics. Yes or no, all of you? What is the important characteristic of an inductor? Current through the inductor may not change instantaneously. Voltage across the capacitor may not change instantaneously. Displacement of the body may not change instantaneously. Yes or no, all of you? A fan is rotating with 1000 RPM speed. If you turn off the fan suddenly, if you withdraw the input given to the fan, then what will happen? It will come to 0 speed. But does it reach to 0 speed in 0 time? No. 1000 RPM to 0 speed, 0 RPM speed, it does not reach or it may not reach in 0 time. Reason is the fan is also offering certain amount of inertia. Yes or no, all of you? Because of the inertia. In mechanical systems, you have storage elements like, mass and spring elements. In electrical systems, you have inductors and capacitors as the storage elements. Wherever you have storage elements, okay, wherever you have storage elements, because of the initial amount of energy stored in the storage elements, they exhibit certain amount of inertia. And wherever there is inertia, definitely they may not accept, okay, they may not accept the sudden change in its respective variable. It might be a displacement, it might be a current, it might be a voltage. Yes or no, all of you, okay? So this is what the main reason why the transients occur. Understand, all of you, okay? Now, the transients occur because of the storage elements like inductor, capacitor, mass and spring element. In mechanical system, mass and spring element. In electrical system, inductor and capacitor. In electromechanical system, all these elements will cause definitely transients. Understand, all of you, okay? So tell me, what are the main reasons for the transients, why they occur? Because of the presence of the inductor and capacitors. You may ask me a question, sir, when the transients are occurring because of the inductor and capacitor, why can't we avoid those elements? But is it really possible to avoid? Is it really possible to avoid, okay, these elements, or can you visualize or realize any physical system without inductor capacitor? Without mass and spring element, any mechanical system, is it possible to realize? It's not. Therefore, you cannot avoid the storage elements in the design of any physical system. Therefore, you cannot avoid the transients. So transients cannot be avoided, but surely they can be controlled. You understand, all of you, okay? You can be the transients can be controlled, but transients cannot be avoided. I hope you understand the point. Now, the objective of the transient analysis is what actually here? What is the main objective? We would like to analyze, understand the dynamics of the system. Okay? When it is reaching to the next equilibrium state, how the dynamics are changing. I would like to know about it. Based on that, I would like to work on the system. You understand? I'll give you a beautiful example here. All of you, look at this. Give you a beautiful example here. Just look at this, all of you. Okay? An elevator. I think all of you know elevator in so many shopping complexes. You have elevators. Yes or no, all of you, okay? Now the elevator is initially at 0th floor, let us say. But your objective is to reach 4th floor. Understand, all of you? You would like to go to 4th floor because you have a shopping at 4th floor, but you are at 0th floor. This is the 0th floor. You are at 0th floor. Now, you would like to reach this 4th floor. What will happen? Obviously, you get into the elevator and you push the button. Understand, all of you, okay? You push the button. Button of what? 4th floor. Then, do you think that elevator will reach to 4th floor immediately in 0 time? Not possible. Because of the inertia, it will slowly picking up the speed and reach to the 4th floor. Yes or no, all of you, okay? Suppose, as soon as you push the button of the 4th floor, if the elevator reaches to the 4th floor in 0 time, is it really a desired response? Definitely not. Yes or no, all of you? Suddenly you are reaching to the 4th floor is not really advisable. It's not a desired response. It's not convenient to us. Suppose if the same elevator is reaching to the 4th floor after 2 hours or 3 hours or 4 hours, let us say, is it really a desired response? Definitely not. Yes or no, all of you? Okay. Suppose if this elevator is reaching to 5th floor, then coming down to 3rd and 4th middle, okay, then going back again to 4th and 5th middle, 3rd and 4th middle, don't worry, definitely you will reach to the 4th floor after some time. Is it really a desired response? Definitely not. Yes or no, all of you? Okay. This is not a desired response. This is also not a desired response. Yes or no, sudden response is not desired response. Definitely not. And this response this response is also not a desired response. But what is the desired response? Hopefully, you will definitely love the response that you have reached this fourth floor with a reasonable amount of delay. Yes or no, all of you? Okay. In control systems, you generally study this is the overdamped response, this is an underdamped response, this is a critically damped response. Understand all of you? Okay. So therefore, I want to understand now. If I have these responses, then I will understand how the system is behaving. When I really purchase the system, then definitely the system will exhibit usually the critically damped. But due to aging effect or due to parameters variations, obviously the characteristics of the system might be changing. But if I know the characteristics, then I will understand what kind of dynamics that the system is exhibiting here. So now my objective in the transient analysis is to understand the dynamic behavior or dynamics. You call it what? Dynamics. Nothing but dynamic behavior. You want to understand the dynamics of the given system, then based on that you are going to take some necessary action, preventive or control action you are going to take. Understand all of you? Preventive or corrective actions, otherwise we can say. You want to really take some action on that. If the response is this, then I would like to see, I have to make the response a little faster. Yes or no, all of you? Okay. If I see the response like this, I will realize I need to suppress these oscillations. Yes or no, all of you? If I get the response something like this, then I'm happy with that. I would like to go ahead with that same response. So students, here, the main object of the transient analysis is to understand the dynamics of the system. I hope you understand the point. So how we understand mathematically, we have some important expression that we will see a little later. Okay, so finally we have understood up to this particular part, steady state, transient state, why transients occur, what are the objectives of transient analysis, all these four important points we have discussed. Yes or no, all of you? The next one is why initial conditions. And what are the initial conditions? How do you define them? Just now we discussed an important point that the main object of the transient analysis is to understand the dynamics of the system. Remember, the dynamics of the systems can be understood only mathematically. Yes or no, all of you? We can understand only mathematically. But how do you do it mathematically here? Okay, whenever you would like to understand the dynamic behavior, you understand that the response, how it is changing with respect to time. That means you need a time response. Yes or no, all of you? Okay. Now, time response can be determined only when you have differential equations. Yes or no, all of you? Okay. Suppose there is a second order system, let us say d square x of t by dt square plus 3dx of t by dt plus 2 into x of t is equal to, let us say, some 10. Assuming that this is a differential equation pertaining to a particular system, related to a particular system. Now look at this. D square plus 3d plus 2 of x of t is equal to 10. Yes or no, all of you? How do you solve a differential equation? You have very important technique. Complementary function, particular integral. Yes or no, all of you? The complete solution, x of t, the complete solution that is x of t is nothing but complementary function plus particular integral. Yes or no, all of you? Now let us look at the complementary function. Complementary function can be determined. It is nothing but what? Homogeneous response. That means I can make d square plus 3d plus 2 of x of t is equal to 0. And finally, I can find the roots of it. Roots are nothing but what? Minus 1 comma minus 2. I hope you understand this. D plus 1 into d plus 2 is equal to 0. You can find the roots. And finally, you got complementary function is nothing but, okay, some constant k1 e power minus t plus k2 e power minus 2t. Now let us look at the particular integral. All of you might be aware, right? You're all good at mathematics, differential equations particularly you must be good at. Otherwise you can't understand all these things I'm telling you. Particular integral is nothing but 1 by d square plus 3d plus 2 into, what is this? 10, right? 10 into e power 0t we can write, because e power 0t is nothing but 1. Then you can substitute f of 0, yes or no, f of d, then f of 0, then you can avoid it, then 10 by 0 plus 3 into 0, 0 plus 2, finally you got 5. So the complete response x of t is nothing but k1 e power minus t plus k2 e power minus 2t plus 5. Don't write all of you, just look at this. I will explain you how, okay? You're going to get all these things and I will dictate some points also, okay? So don't unnecessarily write all these things. I will explain in a particular order, okay? So that you can document it in a proper order, okay? Look at this all of you. What is the complete solution? X of t is equal to k1 e power minus t plus k2 e power minus 2t plus 5. This is the complete solution. But it is still incomplete because k1, k2 are the arbitrary constants. What are they? Arbitrary constants. Now, without finding or without knowing the values of k1, k2, definitely this is an incomplete solution. But we want a complete solution. Yes or no, all of you? Therefore, this k1, k2 arbitrary constants can be determined using initial conditions. Understand all of you, okay? So now tell me why initial conditions are required. Why initial conditions are required? Initial conditions are required in order to determine the arbitrary constants that show up in the solution of the differential equation. Why you want the solution of the differential equations? Because you would like to understand the dynamics. Yes or no, all of you? To understand the dynamics, you require the solution of the differential equation only. It's very clear. We would like to analyze the dynamics of the system. For that you require differential equation. For that you require arbitrary constants. For that you require complete solution. For that you require arbitrary constants. For that you require initial conditions. I hope you understand the sequence here. I want to know first of all the dynamics of the system. For that I need differential equation. For that I need the solution of the differential equation. To know the solution of the differential equation, I need the arbitrary constant values. But how do you find arbitrary constant values? Only using the initial conditions. I hope you understand the point here. Okay. Well, now let's come to another most important here. How do you define the initial conditions? How do you define the initial conditions? Okay. You generally, when you sit in a mathematics class, the mathematics lecturer or faculty will give you a definition that all the conditions, okay, before disturbance taking place in the system, those conditions are called initial conditions. Okay, before disturbance, what are the conditions are there? Those conditions are usually defined as initial conditions. That is a definition given by any mathematics professor. For example, at t equal to 0, the disturbance is coming. And all the conditions, those conditions which exist in the system at t equal to 0 minus, that means immediately before the disturbance taking place in the system, are called initial condition. This is the definition given by a mathematics professor. But remember all of you, in our electrical engineering, because we have two important elements, one is an inductor, the other is a capacitor, okay? And we have another element, resistor also. Current through resistor, current through inductor, current through capacitor. Similarly, voltage across the resistor, voltage across the inductor, and voltage across the capacitor. Totally 6 variables are there. Keeping in mind all these 6 variables and keeping in mind the important characteristics of the inductor and capacitors, we are now defining in a different way. Okay, what is that? Look at this, all of you. Initial conditions are those conditions which exist in the system immediately after the disturbance takes place. That is, t equal to 0 plus conditions are called initial conditions. I think all of you understand this. That is why you take any mathematics textbook or standard textbook you take, okay, you will come across always 0 minus, 0 minus, 0 minus conditions. Understand all of you, okay? But usually, the mathematics professor always defines zero minus conditions or initial conditions. But when it comes to our circuit analysis, because we have a special elements in the circuit, we have resistor, inductor, capacitor, okay, and you have current, voltage, current and voltage, totally three elements, two variables, totally finally how many variables are coming up here? 3 into 2, 6 variables. Keeping in mind these 6 variables and keeping in mind the inductor capacitor characteristics, current through inductor may not change instantaneously. Voltage across the capacitor may not change instantaneously. Keeping in mind these two important characteristics, we define in a different way that T equal to 0 plus conditions. That means what? The conditions which exist in the system immediately after the disturbance takes place. Those conditions are called initial conditions. I hope you understand the point now. Now let us write point by point, all of you. First point let us take now. Okay, steady state. All of you please write down the points. I'll dictate the points here. Steady state. Steady state. A system is said to be in steady state. A system is said to be in steady state. A system is said to be in steady state if it can produce a constant with respect to time before it reaches to next equilibrium state. Before it reaches to next equilibrium state. A system is said to be in transient state if its output response changes with respect to time before it reaches to next equilibrium state. That is called transient state. Okay. Now, question. Why transients occur? It's very important in interview point of view. Why transients occur? Why transients occur? Any physical system will consist of storage elements like mass and spring element in mechanical system. Mass and spring element in mechanical system and inductor and capacitor in electrical system. Inductor and capacitor in electrical system. The transients are observed in the system. The transients are observed in the system due to initial amount of energy stored in. Due to initial amount of energy stored in. Due to initial amount of energy stored in storage elements like inductor, capacitor, mass and spring elements. Okay, I hope you understand why transients are observed or occurred. Yes or no, all of you? Okay. Now, Objective of transient analysis. Objective of transient analysis. Now, objective of transient analysis. The objective of transient analysis is the objective of transient analysis is the objective of transient analysis is to understand the dynamics. What do you mean by dynamics? Dynamic behavior. Okay. To understand the dynamics of the system. To understand the dynamics of the system after the system is subjected to, it's a very important point, after the system is subjected to any disturbance. Hope you understand. Okay, initially the system is in steady state and suddenly the disturbance is taking place. Now we would like to analyze, okay, how the dynamics are, okay, happening in the system before it reaches to next equilibrium state. Yes or no, all of you? Okay. So this is very, very important point. Objective of transient analysis. What is the objective? To understand the dynamics of the system after the system is subjected to disturbance. Next, why initial conditions? So before that, you please note down this particular diagram clearly. Okay, only up to this part you note down. Don't write the remaining part. Okay, I will give you time again. Only this particular part. Equilibrium state 1. Disturbance is taking place at t equal to 0. Moving to transient state and finally it is settling down at another equilibrium state. Okay. And before it reaches to the next equilibrium state, the system is said to be in transient state. And now we would like to understand how the system behavior is changing with respect to time. Okay. We have taken example of what elevator. Elevator is initially 0 floor. We would like to go to 4th floor. But what's happening before it reaches to the 4th floor when you push the button, 4th floor, how actually it is changing, how the dynamics are changing, how the elevator is actually reaching to the 4th floor. Is it reaching after 2 hours or immediately in 0 time or else oscillatory response? Everything we discussed that. Okay. So please note on that very clearly. Then you put a question again. Question, another question here. Why initial conditions? Why initial conditions? Right to the point. To understand the dynamics of any system, mathematically, to understand the dynamics of any system, mathematically, the differential equations are considered. The differential equations are considered. The differential equations are considered. Okay. Now, write down here. Let the differential equation of a particular system. Let the differential equation of a particular system be, write down, d square x of t by dt square plus 3 dx of t by dt plus 2 into x of t is equal to 10. You please proceed up to this particular part. Complementary function. Solution of the differential equation. Complete solution. What is that? Complementary function plus particular integral. How do you find the complementary function? You know how to find it, right? Then particular integral. Then please write down up to this particular part. And call this one as equation 1. where K1, K2 are arbitrary constants. Arbitrary constants. Where K1, K2 are called arbitrary constants. Where K1, K2 are called arbitrary constants. Clear, all of you? Okay. Now, look at this, all of you. So, x of t is the complete solution, but this complete solution is incomplete because of what? Arbitrary constants. Okay, without having known these K1, K2, okay, you do not know what is actually the complete solution. Now, the initial conditions are required in order to evaluate what? K1, K2 values. Please write on that. Now, in order to determine the arbitrary constants, now in order to determine the arbitrary constants that show up in the solution of the differential equation, the initial conditions are required. Understand, all of you? Okay, the initial conditions are required. So it's very clear in interview. Okay, if you get a question that why we need initial conditions, you have to tell all this explanation. And you may get a question that what is the main objective? Why should we really go for transient analysis? Why actually the transients are occurring? Such kind of questions are very frequently asked questions. And remember even the definition of initial conditions also. Definition of initial conditions. Put the heading, definition of initial conditions. Definition of initial conditions. According to mathematician, the initial conditions are defined as those conditions which exist in the system, immediately before the disturbance takes place. Next line. But according to an electrical engineer, the initial conditions are defined as those conditions which exist in the system, immediately after the disturbance takes place. Immediately after the disturbance takes place. Okay, so this is how you define the initial conditions, all of you. Now let us look at the complete picture of how we can see the state of the system with respect to the disturbance. Let us look at that. It's very, very important. All of you can draw it along with me. You can draw it, all of you. Okay. T equal to 0. What's happening here? The disturbance is taking place. Yes or no, all of you? T equal to 0. The disturbance occurred. the disturbance occurred, takes place. Okay. T equal to 0 plus, immediately after disturbance taking place, right? T equal to 0 minus, immediately before disturbance taking place. T equal to minus infinity. What do you mean by infinity? T equal to infinity means nothing but what? Steady state. Minus infinity means what? Before disturbance, the system was operating in steady state. Understand? Okay. T equal to plus infinity. What does it mean? The steady state after disturbance. So please write down here. Immediately before disturbance takes place. Please write down. Immediately before disturbance. Steady state before disturbance. Please write down. Steady state before disturbance. Yes or no, all of you? Immediately after disturbance. Immediately after disturbance. Steady state after disturbance. Steady state after disturbance. Okay, this is completely okay, the state of the system with respect to the disturbance occurred in the system. But usually we create the disturbance in our circuit theory problems by using switching phenomenon here, okay, by the means of switching phenomenon. Usually, okay, we generally use switching phenomenon, okay, to create the disturbance in the system. So therefore, let us now use the term called switching instead of disturbance. Okay, so we can say the switching operation taken place or takes place. What about this? Immediately before switching operation. Please note down, all of you. Switching operation, steady state before switching operation. What about this? Immediately after switching operation. Yes or no? And now steady state after switching operation. Right, all of you? Now this is how the complete picture. It's very, very important. One should really have this entire picture in mind throughout the journey of the transient analysis. Understand, all of you? Okay? It's very, very important. Okay? All of you might have noted down. Okay? Important assumptions. Important assumptions in transient analysis. All of you. Important assumptions in transient analysis. What is that? The first important assumption is that the given system is stable. The given system is, what is that? Stable. Yes, you can do transient analysis only on the stable systems. Otherwise, you cannot do the transient analysis. Yes or no, all of you? The system given must be a stable system. Otherwise, there is no point in doing the transient analysis. It's a very, very important point to be observed. Second important point is that, okay, in the transient analysis, before we carry out the transient analysis, we have to make an important assumption. Okay, that is, another important assumption is that until the disturbance takes place, the system was assumed to be okay in steady state. We know that it is stable, but same time, the system dynamics might be changing from time to time. Yes or no, all of you? But to carry out the transient analysis, the most important assumption is that until the disturbance takes place, the given system is assumed to be in steady state. Please write down that. Okay? The system is assumed to be in steady state until the disturbance takes place. Until the disturbance takes place. I hope you understand this, all of you. Until the disturbance takes place. That means T equal to 0 minus conditions. What do you mean by until T equal to 0? Okay, the system is assumed to be in steady state. That means T equal to 0 minus conditions are same as T equal to minus infinity conditions is equal to T equal to minus infinity conditions. I hope you understand the point. It's a very, very important point to be noted down. Please note of that. We stop here and we see the remaining things in the next session. Okay, so please note on that. T equal to 0 minus conditions are equal to what? T equal to minus infinity conditions. The system is assumed to be in steady state until the disturbance takes place.